Alright, let's look at the homework 6.2, problem number 3. Alright, so let's find the volume of the solid obtained by the region bounded by y equals natural log of 7x, y equals 1, y equals 3, x equals 0, about the y-axis. Alright, so it's a natural log function. Let's take a look at the first one. This doesn't look like a natural log function. And second one here. Alright, so this looks like a natural log of function. And let's see. And actually the third one is not, but so it's going to be a second one or the fourth one. Alright, then we're looking at the, let's see, what's the other ones? Y equals 1 and y equals 3. So those are horizontal lines. Seems like both of them has those pictures there. So let's see here. Alright, so it's just that the shaded region is different. Alright, then it's between y equals 1 and y equals 3, and bounded by, let's see, natural log of 7x and x equals 0. So it looks like, let's see, sorry, here. Alright, this is going to be the correct picture. The fourth one, you can see that it's not, it's actually not using x equals 0. Alright, so we have the right picture. Alright, then we want to rotate about the y-axis. So if you go down and let's see. Alright, so looks like this guy, this one right here, is going to be the picture. Alright, then what we want to do is we want to, maybe I'm going to use this picture. So I'm going to grab this picture right here. Alright, then try to find the volume. So let's do that. I'm going to bring it over here. Alright, so I'm going to just make it a little bit smaller. Alright, then bring it over here. Alright, so we can use the disk method to find the volume here. Alright, so what we want to do is we want to find the volume V, and the disk method is always pi is in front, then integral. Alright, so it's going to go from, so we're going from 1 to 3. So it's going to go from 1 to 3. And the radius is determined by, you can see that the radius is from here all the way to the curve, which is y equals natural log of 7x. Alright, but we have to write in terms of x equals form. So what we can do is we can raise e to the y and raise e to the natural log of 7x. Alright, and exponential function and the log functions are inverses of each other, so you can cancel those out. So then you can just divide through by 7 to isolate x. So we can divide through by 7, so you get e to the y over 7 is equal to x. Alright, so the radius is e to the y over 7. Right? So what we want to do is just a pi r squared, so that's going to be our radius. So e to the y over 7 squared. Oh, maybe I should use blue there. Right? E to the y over 7 squared, and with respect to y. Right? So let's compute this. Alright, so you have a pi and over 7 squared would be 49. So I'll just put it out here. So you have an integral 1 to 3, and so e to the y squared would be e to the 2y dy. Right, then find the antiderivative. So pi over 49 is already there. Antiderivative e to the 2y would be e to the 2y divided by 2, right? Then going from 1 to 3, right? So I'm going to pull out the 2, so you have a pi over 98, right? Then we plug in 3, so e to the 6th power minus plug in 1, e squared, right? So this is the volume we're looking at. So let's try to see if this is correct. All right, oops, not, let's see. All right, so let's see. Where is the... All right, we got that. All right, so it's going to be... All right, volume is pi over 98 e to the 6th power minus e squared. Alright, so let's double check. Oops. Alright, submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.